Welcome, I'm Procaccini, Senior Learning Technologist in the Department of Computing at Imperial College London. Our degree programme aims to develop graduates who have both a rigorous understanding of computer science theory as well as the engineering skills to put this theory into practice. This means that throughout their studies, students do a lot of practical projects, developing many different types of software, from compilers to mobile applications. When any of these projects is undertaken, particularly where tackled as a team, we want the students to be able to draw on the appropriate technical practices to produce high-quality work. We also want them, crucially, to feel the benefit of putting these tools to use, encouraging them to resort to such tools and practices in future projects, not because we told them to, but because they know they will help them produce better results. Looking at current industry practices for developing software, we saw the importance of so-called DevOps practices, the combination of classical development work with the infrastructural and operational work required to deliver working software into production with frequent updates. The work we'll present today summarizes our experience so far in introducing our students to DevOps practices, not as a separate topic, but as an underpinning thread that runs through many of the projects that the students undertake across their degree. Before going ahead on this road, allow me to make a brief digression to refresh everyone's memory about two main subjects of this talk: DevOps and continuous delivery. DevOps can be regarded as an extension building on top of the agile development culture, a set of practices promoting the gradual fusion of development and operation roles, the latter concerned with supporting software after it's rolled out to users. As a result, the responsibilities of software engineers have come to encompass the whole software lifecycle, from design all the way to production support. In particular, software engineers need to develop by thin vertical slices that can be deployed incrementally, design and implement tests for the code to build the confidence that each code increment is of suitable quality, configure and maintain one or more production environments, and finally select and configure the tooling to orchestrate all this. The underlying yet explicit objective of this all is to minimize the time interval between committing a code change and having end users benefit from it in production. Continuous delivery is one of the now quite common practices in the DevOps mix. It extends the sibling practice of continuous integration with one notion: the code that successfully builds and tests, going through a CI pipeline, is a release candidate, deployable at the click of a button. Whenever the deployment is also automated, with no manual steps in the process at all, this is known as continuous deployment. What we eventually dubbed DevOps Lab is an exercise for our Year 2 undergrads that aims at getting the students to know the DevOps culture and its associated practices, and getting students familiar with them by setting up and working with a build pipeline for a simple but real project. The students are then encouraged, and often expected, to apply the skills they gained in all subsequent software development projects in their degree. The exercise specification is quite straightforward. Working on a provided functioning but basic Java web application for trivia queries, students are asked to set up a build pipeline for it, incrementally extend the features of the app, and evolve their build infrastructure from something simple running on their local network to a more sophisticated system of cloud tools. Such evolution is encouraged by the three-stage structure of the exercise. For the first stage, students set up a GitLab pipeline, writing up the appropriate configuration files and deploying the application to a virtual machine in the college internal network. The provided virtual machines are in a clean state, meaning the students must take care of basic system administration, including installing packages, creating users, setting the right access levels, and so on. This is an excellent opportunity for them to familiarize themselves with these sorts of tasks, which they cannot normally perform on our locked-down lab PCs. For the second stage, the internal network's limitation in service availability and scaling potential make the case for moving to a platform as a service provider, Heroku in our case. The students install and use the Heroku command line interface to configure the platform to accommodate their needs and update their pipeline to also deploy to Heroku. For the last stage, we introduce a new feature request, namely the support for PDF query results, with the requirement of implementing this via an external library, Pandoc. This library is not a Java one, so cannot be added to the source code dependencies, and it's not present out of the box in the Heroku environment. As a possible solution, we suggest containerizing the app and its system dependencies with Docker. The students are finally expected to explore the tool, implement the required code changes, and update the pipeline to deploy their containerized application to Heroku. The specific choices of languages and tools selected and suggested for this exercise marry the will to offer a tech stack representative enough of what they might use in the future, with an overall reasonable learning curve. The students are quite familiar with Java from their past projects and modules, and have been using Git and GitLab from day one of their degree. As for the rest, we give them pointers to the official documentation for the suggested tools and to additional tutorial resources that they can follow to dive deeper into particular areas of interest. In this way, we try to strike a balance between giving enough guidance so that all students could complete the basics of the task, and not revealing too many details, so that they had to do some research on their own and develop their skills in reading and understanding technical documentation. In fact, it is another of the very aims of this exercise to train the students to read and understand the official documentation and configuration settings of the tools they choose. This has worked well over the past 2 runs of the DevOps Lab. After a few hours on average of a moderately steep initial learning curve, the students show a remarkable improvement in their ability to navigate new documentation and get started with new tools, as they can draw from the experience of having already gone through the whole configuration and setup with similar services. Once they have worked through the 3 phases of the exercise, we encourage the students to explore the extensive set of features offered by GitLab pipelines, ranging from convenient configuration capabilities to shared runners to Google Kubernetes Engine and Prometheus integrations. We also suggest that they investigate other comparable CI/CD tools like Jenkins or Circle CI and consider migrating part of their pipeline to use a different tool. This allows them to see that the basic process and principles they learned are transferable, even when a different set of tools is chosen, and gives them confidence in assessing and selecting appropriate technology for future projects. For the past 2 runs, we have set the exercise to be completed in groups of 4 and to span 1 academic week. Help is available from staff and teaching assistants during 6 hours of lab support, split in 3 sessions. These logistic arrangements will likely be affected by the restrictions on face-to-face teaching dictated by the global pandemic, but we feel the whole model should be flexible enough to be easily adapted to remote teaching. Working out a suitable way of assessing the students' work turned out to be an interesting task. We have eventually opted for a 20-minute live review session where we ask students to demonstrate their understanding of the practices they followed. Do failing tests successfully block a bad change from being deployed? For the VM deployment, is the application launched in the background with standard output and error streams redirected to a log file? Is there a script or alternative strategy to clean up old instances of the application on every new deployment? What are the benefits and the rationale of platform as a service and containerization? Have security concerns been taken into account while configuring the deployment stages? Are secret API keys exposed in plain text? And so on. The purpose of live assessment is that of prompting reflections and considerations that consolidate the knowledge the students have gained and explored during the DevOps Lab. The learning experience is, however, far from being limited to a self-contained exercise. As we mentioned earlier on, students are expected to keep showing and refining their skill and tool set over the course of their subsequent software engineering projects, most notably their second-year compilers group project, web development project, and their third-year software engineering group project, each spanning a whole term. Overall, we are encouraged by the results of using a short practical exercise early on in the degree program to introduce DevOps skills and techniques, which we believe to be fundamental to engineering quality software. Students who took part in the DevOps Lab in spring 2019 and undertook an internship over the following summer reported that the skills they had acquired during the course helped them speed up the technical onboarding process in their respective companies and fit easily into the ways of working of a professional team. Although tools and technologies will inevitably change with time, we hope that instilling students with these ways of working will serve them well during their future careers as software engineers. Thank you very much for listening.